I'm Dewa Raj Thapa from second semester having roll number 301. Today I'm going to talk about how Robert, Millikan and Harvey Fletcher discover how much charge electrons have by using their oil drop experiment. Now I think the oil drop experiment is like one of the coolest experiment in all of science. Now, before this happened, in 1897, J.J. Thomson discovered the atom have electrons, and he discovered that electron have a negative charge, but he was not able to figure out how much negative charge electron have, because charge is something that can come in a different amount. So scientists wanted to able to put a number on it to figure out exactly how much negative charge each electron had. uh, this was a tricky thing to do through, because you can't just take an atom and pull pull out an electrons and measure its charge. So Bilkin and Fletcher had to do it is use a really clever technique. They used tiny drops of oil and balanced them floating in a mid-air by using gravity and electricity. Uh, and using this technique, they were able to determine how much charge each electron had. I already discussed the oil drop experiment was performed by Robert A. Milkins and Harvey Fletcher in 1909 to measure the elementary electric charge, that means the charge of the electrons. The experiment took place in the Ryerson Physical Laboratory at the University of Chicago. Millikan received the Nobel Prize in Physics in 1923. Here is the robot Andres Millikan. And now here is the principle for this experiment. Millikan's experiment is used for the measurement of charge of an electrons. This method is based on the study of the motions of uncharged oil drop under free fall due to gravity, and charged oil drops in a uniform electric field. By exhausting uniform electric field suitably, a charged oil drop can be made to move up or down or even kept balanced in the field of view for sufficiently a long time sufficiently long time, and a series of the observation can be made. Here is the Milken setup for the oil drop experiment in 1909. Here is the apparatus for this experiment. Let us look some of the method. Let's look here the equipment that Milken used to do the experiment. There is the big chamber and I'm showing a cross section of its here. Now this is the atomizer. Is just like a perfume, Mr. Except instead instead of spreading perfume, is spreading oil. Oil into a tiny little droplets, and these droplets spray out into this area. Now these drops are really tiny, so there is there is a microscope in or telescope in one side of this chamber. So the so the people doing an experiment can look through the microscope and see individual drop. They try to focus on one drop at a time, and here is what they had see. They would see one of these drops slowly floating down here to the ground. Now, well, it's because there is a gravitational force that is acting on the oil drops, pulling acting it pulling downwards downwards. But gravity force is not the only force pulling on this oil drops. There is also a electric field that that is pulling it in the opposite direction. Later discuss some points. Oil droplets in the form of the mist I already discussed are produced by the atomizer were allowed to enter through a tiny hole in the upper plate of the electrical condenser. Now, downward motion of these droplets was viewed through the telescope or microscope equipped with the with the micrometer eyepiece. Measuring the rate of fall of these droplets, Millikan was able to measure the mass of oil droplets. The air inside the cham- chamber was ionized by passing a beam of X-ray through it. The electrical charge on this oil droplet was acquired by collisions with electrons. The fall of these charged oil droplets can be retarded, accelerated, or made stationary depending upon the charge on the droplets and the polarity and the strength of the voltage applied to the plate. Wilkins conclude that the magnitude of electrical charge Q on the droplets is always an integral multiple of the electrical charge. That is, Q is equals to any way. Here, I forgot to write. Here, where n is equals to any integer 1 to 3. Here's the calculations for this. Now, f because now when it floating is in balance, there is they are will equal. So here m sorry uh, q e is equals to mg, where when we find the charge of the droplets, then we can find the charge of the electrons, and q is equals to mg divided by e. Now, one can see how an electron charge is measured by Millikan. Millikan found that all drops had charge that were minus 1.6 into 10 to the power minus coulomb multipoles. Here is the conclusion for this experiment. The charge over any oil droplets is always an integral value of A, that is 1 by minus 1.6 into 10 to the minus 19. Hence, the conclusion of Millikan's oil drop experiment is that the charge is said to be quantized, that is, the charge on any particles will always be an integral multiple of A. Thank you.